So hi everybody, greetings from Orange County, California, where I have been for the past 6 weeks and will be for who knows how much longer. I'm a former NASA scientist turned astropreneur, so that's a melding of the words entrepreneur and astrophysics. And I moved from NASA 30 years ago over to working in the commercial space sector about, I'd say about 8 years ago. And the whole point of this talk here is to give you a context for what the space sector actually does. I know we've got a lot of people on the call right now. I see there are 56 of us, and we all have a variety of backgrounds. And some of you may be quite familiar with the sector, and some of you may not. So I'm hoping to provide some information here that's actually going to contextualize the whole conference for you guys. So why do we look at space? You are what I like to call astro-curious. You want to get involved in space, but the post-COVID-19 global economy will require new knowledge and skills. The world is turned upside down now, and I've had a lot of people actually reach out saying that they're reevaluating their career path because certain sectors will just completely drop out once we all emerge from this. So when you look back towards the Earth, you actually don't see market segments. You see a global economy, and we've been heading towards globalization for quite a while, and that's part of the reason we have this pandemic right now. But in fact, when you talk about markets, it is the global economy is a single market. And every resource that you've had on Earth already exists in space. If you know anything about solar system origins, you understand in terms of minerals and other elements that everything we have here is out there. And we have access to limitless resources in space without having to worry about conflict, without having to worry about ecologic concerns or legacy claims to resources and materials. And because there are no borders, we do need international cooperation. And I know some of the experts here have spoken about that quite a bit today, but international cooperation is key. And there's no gravity, which, as we all know, is actually a very unique environment. It's kind of cool because it gives you unique manufacturing and processing opportunities, which I'll get to in a second. So in the past, missions were cost billions of dollars, right? NASA has a multi-billion, $18 billion a year budget. The Hubble Space Telescope at the time back in the 90s cost about $4 billion. That was my first job out of college. I started on the Hubble before it launched. The Hubble launched on April 24th, 1990, so 30 years ago. And so I started a little bit before that. So those of you who like to do math can figure out how old I am. And I also worked on the Galileo spacecraft. That's the spacecraft I used to get my PhD. And these were all billions of dollars of investment, years and years and years of time. So you can see here, this was taken, I am right here, 30 years younger. This was taken a few days before the Hubble Space Telescope launched. This was our director, Riccardo Giacconi, who eventually went on to win the Nobel Prize. So when I talk about space being glamorous, it's stuff like, walking down the hall from somebody like this. That was a great opportunity. Nobody ever looks bored when you tell them you're working in the space sector, right? It's very cool. We're all very inspired and very excited about it. And now the question is, how do you get involved? And is it necessary to even get involved? So we've moved in terms of technology development from these huge room-sized computers in the 70s to these Macintoshes in the 80s to the phone that you have in your hand right now, which has thousands of times the memory and computing power of even something from the 80s. So when we think about our future, we have gone from, because of the miniaturization of electronics, to this handheld satellite known as a CubeSat. Some of you may already be familiar with this platform. I'm holding this in my hand. It's about the size of a mobile phone, and it's a self-contained unit. You put solar panels on the outside, and it launches and takes its own data. You can build one of these depending on the kind of sensors you put on it for a few $100,000 US, which is crazy. We were talking billions of dollars earlier, remember, and now we're talking about a few hundreds of thousands. So we've gone from the phones to these handheld satellites. And what about going to Mars? Before anybody asks me, Australia has not gone to Mars. I know a lot of people will see when I show something like this, it's more a testament to my ability to Photoshop than anything else. So the plan, though, in the longer run is a lot of people do want to get to Mars by the 2030s and the 2040s. I don't think it's unreasonable for us to actually send humans there. So we're talking about a post-COVID planet right now, right? Everybody's rethinking where they're going to go, what are the opportunities going to be. There are already a lot of opportunities. There's been extensive use of space-based images, such as these you see here, from outer space. So in the area of agriculture, this is in South Africa, you can look at farms. In Indonesia, you can look at fires that are set on the palm oil plantations. You can look at construction sites. This was in New Zealand. Each of these kinds of data have people associated with them, and there can be all kinds of legal issues that arise from having people involved. There are property interests, there are employment interests, and in the case of New Zealand, I thought this was an interesting one. The indigenous people were concerned about construction being done on their land, and they couldn't get a property claim, so they actually went and got satellite data and looked at exactly where construction was being done and matched that to maps to be able to stake a claim to land that really belonged to them where there was illegal construction going on. So agriculture, disaster relief, and construction. So the other thing that I think is really important, and that's going to be tremendously important in the coming decades, is supply chain. If you live in the US, there are certain things that everybody's out of. I can't buy fresh tomatoes anymore or flour. Everyone talks about not having toilet paper in the US. I'm sure everybody's got their own shortages, just depending on where your supply chain comes from. And satellites are really valuable in this regard because they can help you figure out where roadblocks are and keep really good track through space of your entire fleet of trucks and ships and whatnot. So when you're talking about being in outer space, I mentioned earlier about microgravity being a really amazing environment, and we already have a lot of benefits here on Earth from technology that was derived for space. And I'll give you two quick examples here. This drug on the left is called Prolia, and it's a medication that is injected a couple times a year for people who are subject to bone loss. So typically here on Earth, that would be elderly people who you don't want them to fracture a hip if they fall down, so you give them this medication to strengthen their bones. Interestingly enough, astronauts who spend an extended period of time in space, they have a similar issue with bone loss. So this drug benefits them as well as us, and you can do trials in space with it very easily. In fact, they sent a bunch of mice up there who lost bone mass very quickly and were able to reduce the time of their clinical trials for this particular medication much more quickly than they would have been able to do it on Earth. And so here we have crystallization. This is also a very interesting one. We can form crystals here on Earth for the purpose of building proteins for medication, but because of gravity, you can see the crystals are pretty fragmented and not very well organized. When you remove the pull of gravity from a very tenuous structure, something like this here on the right, you can see you get much larger, sturdier, cleaner crystal formations. So those can serve as the building blocks for medication as we move forward. And in the case of, say, vaccine production, there are implications here for that. We know that certain kinds of bacteria grow very rapidly in space and others are really quite sluggish. And that would have another implication for the abuse of antibiotics, right? So the issue here is workforce. This is my take on it after having been in the sector for the past 30 years. There are reports out there that say by 2040, the space ecosystem will be worth $3 trillion. So we will need people to come in to do everything in finance, marketing, medicine, social economic sectors, law, as well as education. And the issue here is that so far we've been in a realm mostly of tech demonstrations. So you've gotten scientists and you've gotten engineers who've come on board and done a lot to prove certain technologies work. And we are now actually in a realm where we got to take those and commercialize those to build a true ecosystem. Everybody has done projections on use of satellite imagery and all the other kinds of things that you can do. $3 trillion sounds really great, but it's not clear that the workforce will exist unless we get people from all of these sectors, including you guys, involved. We need expertise from people in all of these areas to actually come on board. So in terms of the workforce, one of the things we can do immediately is training. And this is not just for high school and university students. We have sent experiments to the International Space Station. Here's some astronauts working on experiments. We've sent up 7 of those so far, and the astronauts will install the experiments and send data back down to students here on Earth. It's an amazing experience, and we've worked with students from Australia on this, as well as from Singapore. Now, with regard to older people, university students as well as professionals, we do different kinds of workshops. The hands-on workshops that we do in astropreneurship involve case studies, looking at space startups and figuring out what works, what doesn't, what are their strengths, and what are their weaknesses. You get an overview of who's doing what in the sector, not just the big ones like SpaceX, the companies that everybody already knows about, but there are a lot of other up-and-coming entities that really are going to contribute in a significant way. So we look at those too, and the level of detail that we provide really depend on the level of expertise of the people who are attending the workshops. And we also do these hands-on CubeSat workshops. You remember that satellite I was holding a couple slides back? This is one of these being held by a couple students. This was at Swinburne in Melbourne last May. So with regard to the ISS, the International Space Station projects, we've launched all of these experiments to date. And the ones from Australia are magnetic fluids, looked at tooth decay, and then the kids sent up an experiment just a couple months ago on plant growth. So there's an interesting question here. This was really my first experience with space law, working with the students from Australia. Our magnetic fluid experiment, this looked at a solution where magnetic particles were suspended, and the students wanted to know what happens if you don't have gravity. Will the particles stay suspended, or will they become, sort of convected and look kind of different? So we launched that experiment in May of 2018. That was fairly straightforward. The students put together the payload, they mailed it to the US for integration. SpaceX took it up on the rocket, astronauts installed it, everything went well. In July of 2018, the Australian Space Agency was founded. And the next launch scheduled for 2019, we actually had to provide legal clarification. There were issues that came up, as we had discussed earlier by Alexandra Seneda, of overseas payload. We had to address those. We had to figure out who owned the material. We had to figure out who retains ownership after launch. And I worked closely with Kim Ellis from the space office at Swinburne to figure all of this stuff out. And just parenthetically here in Singapore, there haven't been any issues with this because nobody's thought about it. And it's still kind of the Wild West. But in Australia, I think we may have been among the first to address this issue of who actually ends up owning an entire payload. And in our case, it turned out that when we had put our contract together with our supplier, we'd done the right thing. They retained ownership the whole time, so there's no actual transfer upon launch, which sometimes does tend to happen. So then in March of 2019, we provided that clarification. And then this year in 2020, we actually had a rush. Now, these are student experiments. So the rocket that you get stuck onto to go up, you kind of are at the mercy of the larger companies, the larger payloads. And so they will sometimes shift us around. And traditionally, what they'll do is they'll slip your schedule later. But this year, we got scooted earlier to February, which meant everything had to be done, including the paperwork. But fortunately, since we had gone through this exercise in 2019, at this point we were able to go through very quickly and file the right forms and get this up. So I always like to end with a call to action. What I really want you guys to do is to take your expertise, whether it's in the law or any of the other broader sectors I mentioned here or anything else, and get yourselves involved, because we really do need to move to a true ecosystem, which requires input from people from all backgrounds, right? Not just STEM nerds like me. And one of the best that you can actually do this is to find training. I'm going to leave this QR code up for a minute, and it will be on the slides later if you want to look at that as well. We do offer these workshops, and we're going to offer a free workshop and case studies on May 12th. And it's going to be a webinar. In light of the COVID crisis, I do think it's important to let people know what kind of options they have. And we'll work on these case studies, and then eventually when we have the longer workshops, you'll be able to publish your findings online, so there will be some kind of lasting legacy of what the space community as a whole thinks of these companies. So that's going to be really helpful for everybody. So I think I might have a couple more minutes for questions. Is that true, Sam?
Sorry, yes, we do have time for a couple of questions. Does anybody have any questions? Thank you so much, Bidushi, by the way, for such a great presentation. I think in particular, it's so helpful to understand what the experience is of someone like yourself going through that system of and the legal side of things as to who owns the payload. So I think that's of particular interest, and it'd be great if we could have time to get some more details on that. But we do have questions from our audience. So from Deepa, what are the ethical concerns on clinical trials in space? Do you have any insight on that?
So yeah, the clinical trials basically are done on animals. With regard to humans, astronauts are basically a human lab. They are constantly having their blood sampled, their oxygen rates monitored, their whole body basically serves as a laboratory in space. And in terms of taking these medications, like the one for bone loss, they have, offered it, they've done it in terms of animals. I don't know what the ethics would be. That's, I think, something that each country would have to decide. Now, when you go up into space, you are still a citizen of your country of origin. So I would think that the rules that dictate clinical trials for humans would still be in place when you get up there.
Thank you. Do we have any other questions for Bidushi there? Please type them in the chat. Just a big thank you from Deepa there.
I guess everybody understood everything. I love that.
It was a great presentation, yeah, no confusion. So thank you so much then. I guess we'll hand over to Rebecca. We'll thank you. Please send through your virtual claps and applause for Bidushi's presentation there.